Algebra I 11.5a, Dividing with Radicals. When we compare these two, the square root of 36 over the square root of 9 and the square root of 36 over 9, the square root of 36 is a 6 and the square root of a 9 is a 3. We've got 6 over 3, that equals 2. And if we simplify inside of here first, 9 goes into 36 4 times, so we've got the square root of 4, which is 2. See how it's the same thing? The division property for radicals. Remember, we talked about this in the last video. For any non-negative real numbers, a and b, as long as b is not 0, if we've got a fraction inside of our radical sign, we can split it up so that there's a little radical up here and a little radical sign down here, see? And we can flip it around. If we've got these first, it'll equal this one. See? We can flip this around. Okay? So if the numerator and denominator of the radicands are perfect squares, we can simplify them. Square root of 25, that's 5 times 5, and 9 is 3 times 3. We take one of these, because this is essentially 5 squared over 3 squared, isn't it? When we find the square root of this, we just take one of them, don't we? Our answer is 5 over 3, 5/3. For 1/16, what times what equals 1? 1 times 1. And we got a perfect square 16. What times what equals 16? 4 times 4. Take one of them. We've got our answer. We can also simplify a fractional radicand to a perfect square. If we've got 18, the square root of 18 over 50, well, 18 is 9 times 2, right? And that's a perfect square. So we pull out the perfect squares from them like we've done before in that previous video. There'll be links to that in the description. We find the square root, the largest one, perfect square. We got a 9 times a 2. And this would be 25 times 2. And 2 over 2 equals 1, doesn't it? So essentially we've got 9 over 25. And the square root of 9 is a 3. And the square root of 25 is a 5. Our answer is 3/5. The square root of 16 is 4. It's 4 times 4. And 9 is 3 times 3. That's a 3. We end up with 4/3. See? Just pull one of them out. See? Doesn't matter which one. So, that's the division property for radicals. Okay? It could be under one big radical sign, or the numerator can be under 1 and the denominator can be under 1. So we could use that division property for radicals to simplify and divide them. We've got the square root of 27 over 3. That's essentially 3 goes into 27 9 times, doesn't it? So we're doing the square root of 9. We can pull out perfect squares. 9 times 3 is 27. 1 times 3 is 3. That makes a 1, doesn't it? We end up with 9 over 1, which is a 9. The square root of 9 is 3. See? Let's try it with variables. We've got the square root of 30a to the 3rd power over 6a to the 2nd power. Now remember, the quotient rule says, like there's a little invisible 1 by this x, isn't there? So that would be x minus 1, because the quotient rule says to subtract quotients when we're coming down. So that would be x to the 4 minus 1, or x to the 3rd, see? So because these are both a, we can subtract these. If that was a b, we couldn't do it. They've got to both be the same variable, the same base, okay? So this is essentially 5 times 6, a to the 3rd, over 1 times 6, a to the 2nd. That makes a 1, doesn't it? We could have even simplified it as 6 goes into 30 5 times, right? When we have a to the 3rd take away a to the 2nd, we end up with just a. And it's going to stay up here because the a to the 1 is up here, see? Because this is a to the 3rd minus 2. See? So the a stays up on the top. All right? So there's a little saying, And it essentially just means this: the radical of a quotient is the quotient of the radicals. And a lot of times people can remember the division property for radicals by remembering this silly little saying: the radical of a quotient is the quotient of the radicals. See? All right. Our next video, 11.5b, we're going to talk about rationalizing the denominator. I'll explain what that means. And of course, any of the previous videos that we did for Chapter 11 are going to be in here. So if you're confused, you should probably go back to 11.1 and start watching, or find where you're lost and start watching from there, because each video builds upon the next one to the next one. All right? So if you're missing something and you're confused, there's a hole in your education that needs to be filled. All right? There's something that you missed. Okay? All right, so let's rationalize denominators, and I'll see you next video. I hope you're doing all right. Bye.